Welcome to Physics Can Be Fun with me, Stephen Thomas. Today we're looking at carboxylic acids as part of organic chemistry. Now, they are compounds that have this carboxyl group. See, double bond. This is the first time we come across double bond oxygen, then a single bond oxygen, OH. So that reminds us of the alcohols, the hydroxyl group, but with a double bonded oxygen it becomes a carboxyl group, and this whole group is called the functional group of the carboxylic acids. So the carboxyl group makes up the carboxylic acids. So if we had just a one carbon carboxylic acid with a hydrogen on the end to satisfy that carbon, we would have, and we must remember, methane, ethane, propane, butane, pentane, hexane, heptane, octane, but now the name changes to oic acid. So a one carbon would be methanoic acid, oic acid, and they all end in oic acid. Now let's make it now a two carbon acid. Do you see it's still got the functional group? We number the carbons from the functional group. So this would be carbon number 1, that would be carbon number 2. And this is now not meth, but ethanoic acid. And this would be ethanoic acid. Now, as the name implies, these are all acidic substances. In other words, they sour, they kind of burn. If you can think of ants and lemons and all the organic compounds, anything that you've eaten that tastes sour would have an ending with a C double bond O, OH, a carboxyl group. And so we could continue on. Let's put this right on the end. And let's just put carbons in between and just make a nice long chain ending in a carboxyl group. And there we go. So what would that be called? Meth propanoic acid. What would that be called? Butanoic. What would that be? Pentanoic acid, hexanoic acid, heptanoic acid, octanoic acid if it's got 8 carbons. And therefore octanoic acid. So these compounds, their physical properties, they all tend to be liquids at room temperature. Again, the reason being, whenever you see an oxygen, tends to have hydrogen bonds. So their functional group is this C double bond O, OH. That's its functional group. And if we were to look at their molecular formula, we would say that they would have CnH 2n plus 2, and then 2n plus 2. So each hydrogen's got 2, then there's 1 on the ends, there's the plus 2, and then O2. So that would be how we could work. So for octanoic acid, it would be C8, H twice 8, 16, plus 2, 18, H18, and then it would be O2. And that would be the molecular formula.